Okay, in section 4.2, they want us to graph some polynomial functions. So the first thing we need to talk about is what are some things that we know about graphs of polynomial functions. Well, first of all, we can talk about how many real zeros are they going to have. Well, the maximum number of real zeros, will always equal the degree of the polynomial function. So if it has a degree of 4, it can have at most 4 real zeros. Degree is 7, it could have at most 7 real zeros. Now I don't know exactly how many it has, but that's the most it could have. The maximum number of x-intercepts, well, the x-intercepts are where we have the real zeros, so it's also equal to your degree. And then the maximum number of turns that a graph could have. And a turn is where you're going to see a max or a min, and that's always equal to the degree minus 1. So let me give you an example. If I were to have f of x equals negative 3x to the fourth plus 2x cubed minus x minus 4, it would have at most 4 real zeros because the degree of this function is 4. It would have at most 4 x-intercepts, and it would have at most 3 turns. And so I think you've got a couple of questions about that. The next types of questions, they want you to graph some polynomial functions. So I just want to look at one. I'll try number, I don't know, we'll do number 13. Problem number 13 is f of x equals negative x cubed minus 2x squared. And I'm going to use the calculator to help me with that. So I'm going to go to my y equals, I'm going to clear out what's in there, and I'm going to type in this particular problem. Negative x cubed, I'm looking for at most 3 zeros and 2 turns. Let's just see what it looks like and see if I can kind of get an idea. Oh, my window's not very good. Let me fix this window. If you hit zoom and then 6, it takes you to a standard window, which should be a good start. And that looks pretty good to me. So I see a 0 at negative 2 and 1 at 0, probably. Let me go to my table is on ask, so I'm going to change it to auto just to get some good data there. Negative 2 I think is a 0, and 0 looks like it's a 0 to me, and both of those are. So those are my only 2 zeros because of the way that it's drawn, because I know it can't have any more than 2 turns, and what I'm looking at right now already has 2 turns, so those are my only zeros, negative 2 and 0. So over here on my graph at negative 2 I'm going to put a dot, and at 0 I'm going to put a dot. Okay, so next thing I need to do is I need to find a point to the left of negative 2. So using the table, I'm going to look at maybe negative 3. Negative 3 is 9. Well, in this case, that would be off this graph. So it's somewhere up around here. So I know that this is coming down. And remember, your polynomial functions are smooth and continuous. Okay, so now I need to figure out where is it going in between here. I know it goes up. Actually, it goes down right there, sorry. And I need to find that point. So I'm going to look at this graph, and that would be a minimum. So I'm going to push second trace 3. I need a left bound and a right bound. And I'm going to plot that point at negative 1.3, negative 1.1. So approximately, let's see, approximately here. Okay, so I'm looking for something that comes down this way and then, whoa, I missed that point. Sorry, it's hard on this thing. Smoothly goes here, and then, well, where is it at 1? I should have checked that before I started drawing this. At 1, it's at negative 3, and at 2 at negative 16. So 1 negative, it looks like I'm about to hit that one if I'm making it smooth. 1 negative 3, and then 2 negative 16. So it's going like that. So not the best because it's really hard to draw on this thing, but make sure it's real smooth, and then that's a good graph. And that's what you got to do on most of these problems in section 4.2 is just draw a graph. And all I want you to do is try to hit the zeros, try to hit if there's a max or a min, try to hit those points and kind of show what it's doing on the ends, whether it's going up or down. The last thing in section 4.2 talks about what's called the intermediate value theorem. And what that tells me is it'll tell me for sure if there's a zero between two numbers. Because the way a graph works, if I plug in a number like, let's say I plug in 1 and I get 4. So I know the point 1, 4 is on the graph. And then I plug in 5 and I get negative 2. If I plug in those two and one gives me a positive and another gives me a negative, then somewhere in here, because these graphs are continuous, there would have to be a zero somewhere. It could be doing this, it could be going this way and still going down. It's doing something, but it's crossing zero somewhere between 1 and 5. If I get two positives, when I plug in the numbers, like if I were to get 1, 4, and then 5, 2, I don't know if there's a zero or not. I can't say for sure there's not one because it could loop down here and then come back up and there could be a couple of zeros in there, but it could also do something like this and there not be a zero in there. So if the signs don't change, you can't say for sure. So I'm going to do an example, and I think using your calculator is the easiest way to do this, but I'll do one, let's say problem 37 in your textbook is f of x equals x to the fourth minus 2x squared minus 6, and they want to know, is there a zero between a, which is 2, and b, which is 3. So I'm going to use the calculator. You can plug in 2 and plug in 3 and see what you get, but I think it's easier to type this in your y equals and use your table. So if I go to y equals, I would type in x to the fourth minus 2x squared minus 6. And then if I use the table, they want me to find when x is 2, I get 2. And when x is 3, I get 57. So when I plug in 2, I get 2. When I plug in 3, I get 57. There is not a sign change between 2 and 57. So I have to say I can't, I'm not able to determine whether there is a zero, determine if there's a zero between 2 and 3. So that's where I'm at. If the signs do change, if one was a negative and one's positive, I would say yes, there's for sure a real zero between those two. And that's pretty much 4.2 all summed up.